In the beginning, there was observation, not in the mythological sense of creation myths that populate human consciousness across cultures and centuries, but in something far more fundamental. There was the observer, conscious, aware, questioning. And with that observation came reality itself, emerging like a photograph developing in the chemical bath of potentiality, shaped by the very act of being witnessed. This is not metaphor, though it reads like poetry. This is the strange, undeniable conclusion toward which modern physics has been inexorably drawing us for more than a century. The observer is not a passive witness to a pre-existing reality, standing apart from the universe like a person peering through a window. Rather, the observer is woven into the very fabric of what is. Consciousness and physical reality are not separate realms awkwardly tethered together by mysterious bridging laws. They are expressions of something more fundamental, more subtle, more magnificent than we have traditionally allowed ourselves to imagine. We stand at a peculiar moment in human intellectual history. For nearly 4 centuries, since Descartes codified the separation of mind and matter, we have inhabited a worldview that treated consciousness as an oddity, a ghost in a machine, an intrusion of the immaterial into the material, a problem to be solved. Physics, that most successful of scientific enterprises, built an impressive edifice of understanding about the external world while treating the observer as an irrelevant footnote, a mere instrument for measurement whose own nature could safely be ignored. But quantum mechanics changed everything. Quietly, without fanfare, it demolished the distinction between observer and observed. And we have spent the decades since that revolution trying to look away, trying to pretend that the most successful scientific theory ever developed does not actually say what it so clearly says about the role of consciousness in creating reality. This journey we are about to take together is an invitation to look directly at what has been staring us in the face. It is an exploration not of what quantum mechanics tells us about reality, if we squint and interpret it favorably, but what it actually says when we read it carefully, without flinching. And it is an examination of what this means for our deepest understanding of what we are, what consciousness is, and what relationship exists between the awareness we experience and the universe that surrounds us. We will move through 3 great territories of understanding. First, we will journey into the quantum realm itself, that strange, twilight domain where the rules are different, where a single particle can be in multiple places simultaneously, where the act of measurement fundamentally changes what is being measured. We will see how this realm of atomic and subatomic phenomena underlies everything we perceive as solid, stable, and real. Second, we will explore the philosophical implications of what quantum mechanics reveals. We will grapple with questions that have troubled the greatest minds in physics. What does it mean for a thing to exist before it is observed? Is there such a thing as objective reality, or is reality in some fundamental sense observer-dependent? How can mind and matter be made of the same basic stuff if they seem so different? Third, and most ambitiously, we will consider what it might mean for consciousness to create reality not just in the technical, instrumental sense that quantum mechanics requires, observation causes wave-function collapse, but in a deeper, more mystical sense. If the deepest level of physical reality is fundamentally mental or experiential in nature, what becomes of the hard distinction between mind and matter that has dominated Western thought for so long? These are not idle questions. They have practical implications for how we understand ourselves, how we treat the natural world, and what becomes possible when we accept that consciousness plays a fundamental role in shaping reality rather than being a mere epiphenomenon, a useless byproduct of blind physical processes. But before we can explore these territories, we must become comfortable with the quantum world itself. We must learn to think in ways that our everyday experience does not prepare us for. We must cultivate what the physicist Niels Bohr called complementarity, the ability to hold contradictory ideas simultaneously without collapsing them into false reconciliation. And we must learn to find beauty in uncertainty, to recognize that the deepest mysteries are not bugs in our understanding but features of reality itself. This is not a journey that can be undertaken passively. Reading about quantum mechanics is somewhat like reading about swimming. At some point, you must wade in. You must allow your intuitions to be surprised, your certainties to be questioned, your comfortable assumptions about what is real and what is merely apparent to be challenged. The stakes are high. What we believe about the nature of reality shapes not only how we think about physics, but how we navigate our inner lives, our relationships with others, and our relationship with the living world of which we are a part. If consciousness truly plays a role in creating reality, not merely measuring it, but actualizing it, then the quality of our awareness, the clarity of our attention, the compassion embedded in our consciousness becomes a matter not merely of personal development or psychological health, but of fundamental importance to the fabric of existence itself. We live, whether we recognize it or not, at the frontier of human understanding. The questions we are about to explore sit at the boundary between physics and philosophy, between science and spirituality, between what can be measured and what must be experienced. This may make some uncomfortable. Comfort, however, is not the purpose of this inquiry. Truth is. Or rather, the relentless pursuit of it, knowing full well that truth may be stranger, more wonderful, and more humbling than anything we have yet imagined. So let us begin. Let us step together into the quantum field, that seething sea of possibility that underlies all manifest existence. Let us see what it can teach us about the nature of consciousness, the character of reality, and the extraordinary possibility that the universe is fundamentally creative, a work of art in continuous co-creation between mind and matter, between consciousness and the quantum field. The observer awakens. And in that awakening, reality comes into being. Part 1. The Quantum Realm. Chapter 1. The World at the Smallest Scale. There exists a realm beneath the realm that our eyes show us. Below the level of atoms, below the scale where a millimeter would be like the diameter of the observable universe, there is a domain governed by rules so different from those of everyday experience that when physicists first encountered them, many simply refused to believe their own mathematics. This is the quantum realm, and understanding it requires us to release our grip on what we think we know about how things work. At the scale we inhabit, the scale of tables and chairs, of human bodies and mountains, the universe behaves in ways we can visualize. Objects have definite positions. They move in smooth, continuous paths. An electron is not here and there. It is in one place or another. If it starts moving, we can in principle trace the path it followed. The world unfolds like a film, frame by frame, each moment determined by what came before. But when we look at the building blocks of this familiar world, everything changes. Beneath the atomic surface, particles behave in ways that baffle our intuition. An electron, for example, is not a tiny ball spinning in space. It is not a little marble with a definite position and velocity. Rather, it exists in a state of profound ambiguity. Before it is measured, an electron exists in a kind of ghostly superposition, a mathematical description that says it is in many places at once, with different probabilities, hanging in potential until the moment of observation. The moment an instrument detects it, the state collapses. The electron chooses a location. The many possibilities collapse into one reality. But what was it before we looked? Where was it? The honest answer, the answer that physics forces upon us, is that these questions do not have meaningful answers. The electron was not anywhere in particular. It existed as a wave of probability, a cloud of potential outcomes, until the very act of looking forced it into being at a specific place. This is not a failure of our knowledge. This is not a sign that we need to look harder with better instruments to find out where the electron really is. This is reality. At the quantum level, existence and observation are bound together in an inseparable way. Consider the famous double-slit experiment, perhaps the clearest window we have into the quantum nature of reality. Imagine an electron gun, a device that fires electrons one at a time toward a barrier with two slits in it. Behind the barrier sits a detector screen that lights up wherever an electron hits. If the electrons are particles, like tiny bullets, we would expect them to go through one slit or the other. Some would go through slit A, some through slit B. On the detection screen, we would see two bright vertical lines directly behind each slit, a pattern we might call a particle pattern. But this is not what happens. Instead, we see a pattern of alternating bright and dark stripes, the same pattern we would see if the electrons were waves passing through both slits simultaneously, interfering with each other. Some regions where the waves amplify each other, bright stripes, and other regions where they cancel out, dark stripes. This is the wave pattern. So electrons behave like waves. Except that here is the catch. The moment we set up a detector to watch which slit each electron goes through, the pattern changes. Now the electrons behave like particles. They go through one slit or the other, and we see the particle pattern. Two lines, no interference. The electron knows whether or not we are watching, and it behaves differently depending on whether or not we are. When unobserved, it exists in a state of wave-like potential. When observed, it becomes a particle with a definite path. This is not a trick of the equipment. This is not a limitation of our measurement technology. Physicists have performed this experiment countless times, always with the same result. And the consequence is strange and unavoidable. There is something about the act of observation that creates reality. Not merely reveals it, but creates it. The mathematics that describes this phenomenon is called the wave function. Every quantum system is characterized by a wave function, a mathematical object that encodes all possible states the system could be in. For the electron traveling through the double slits, the wave function is spread out, describing the electron as being everywhere at once, with different probabilities at different locations. But the wave function has a peculiar property. It seems to be merely a description of our knowledge. It describes the probabilities we would assign to different outcomes if we were to measure the system. The moment we actually perform the measurement, the wave function collapses to a single outcome. The probability wave becomes a definite fact. This is where things get deeply strange. The wave function describes possibilities, potentials, could best. It is not made of anything physical in the conventional sense. It is more like a description of knowledge or information. Yet the moment we extract information from the system through measurement, the system becomes physical in a new way. The possibilities crystallize into a single actuality. Put differently, before measurement, a quantum system exists in a state of indeterminacy. It is not that we merely don't know what it is. Rather, there is literally nothing determinate to know. The system does not have definite properties independent of our attempt to measure it. The properties come into being through the measurement. This seems impossible. It seems to violate everything we know about how the world works. We assume that things are what they are independent of whether or not anyone is looking at them. A cat is in the box or not in the box, whether or not we open the box to check. But quantum mechanics says that at the fundamental level, reality does not work this way. Erwin Schrödinger, one of the founders of quantum mechanics, famously illustrated the strangeness of this with his cat paradox. If we place a cat in a sealed box with a quantum-triggered poison, the cat exists in a superposition, both alive and dead simultaneously, until we open the box and observe it. Schrödinger meant this as a reductio ad absurdum, an illustration of how ridiculous it is to apply quantum rules to everyday objects. But the implication is clear. If quantum mechanics is correct at the fundamental level, then something must be going on that prevents such superpositions from occurring at the macroscopic level. That something is probably decoherence, the process by which quantum systems become classical. A macroscopic object like a cat is constantly interacting with its environment, constantly being observed by the heat and light and air molecules around it. These interactions cause the wave function to collapse rapidly, multiple times per second. The cat never exists in a true superposition. It exists in one state or the other, with the probabilities collapsing so quickly that we never see the intermediate quantum behavior. But at the level of atoms and electrons, things are different. An isolated quantum system can exist in superposition. An electron can be in two places. A photon can go through two slits simultaneously. An atom can be in two different energy states. And the mathematics of quantum mechanics describes all of these possibilities perfectly. What quantum mechanics does not do is explain what these possibilities are made of, where they exist, or why measurement causes them to collapse into a single outcome. It simply says that they do. This is not a weakness of the theory. In fact, quantum mechanics is the most spectacularly successful theory in the history of science. Every prediction it makes, down to absurd precision, is confirmed by experiment. But its success comes at a price. It forces us to accept something that seems fundamentally unintelligible about the nature of reality. The physicist John Bell proved something remarkable in 1964. He showed that no theory based on local realism, the idea that reality exists independent of observation, and that nothing can travel faster than light, can account for the correlations observed in quantum entanglement. Experiments done over the following decades confirmed that Bell was right. The quantum predictions are not just different from what local realism predicts. They are incompatible. Entanglement is perhaps the most startling feature of the quantum realm. When two particles become entangled, they form a single quantum system described by a single wave function, even if they are separated by vast distances. Measuring one particle instantaneously affects the state of the other, even if they are light years apart. This seems to violate the principle that nothing can travel faster than light. But what is being transmitted is not energy or matter, it is correlation. The two particles remain in superposition until one is measured. The moment one is measured, both know the result and adjust their state accordingly. No signal needs to travel. The correlation is intrinsic to their shared wave function. Albert Einstein famously called this spooky action at a distance, and argued that quantum mechanics must be incomplete. There must be hidden variables, he thought, additional information about the particles that we simply do not have access to. These hidden variables would explain the correlations without requiring instantaneous connections between distant particles. But every attempt to construct a viable hidden variable theory has failed. And the experiments testing Bell's inequalities have consistently shown that the quantum mechanics predictions are correct, and the hidden variable predictions are not. Nature actually is non-local. Distant entangled particles actually do respond instantaneously to each other's measurements. What does this mean? It means that reality at the quantum level is fundamentally holistic. Entangled particles do not have independent, separate existences. They are aspects of a single unified whole. The universe at the smallest scales is not made of independent pieces that happen to be correlated with each other. It is woven together in a way that transcends space. And at the deepest level, the entire universe is entangled. Every particle that has ever interacted with every other particle shares in a single, interconnected wave function. We are not separate observers standing outside reality, measuring it from a distance. We are woven into it at the most fundamental level. Our measurements, our observations, our consciousness are not external to the quantum world, they are part of it. This is the foundation upon which we must build our understanding. The quantum realm is real. The rules that govern it are confirmed to absurd precision by countless experiments. And those rules tell us something profound, that observation and existence are intimately connected, that reality at its deepest level is not independent of consciousness, and that the universe at the smallest scales is fundamentally whole, fundamentally unified, fundamentally beyond our everyday intuitions. But what does this mean for consciousness itself? And how can we understand the passage from the quantum realm to the classical world we inhabit? These are the questions we must now explore. Chapter 2: The Wave Function and its Interpretation. There is a paradox at the heart of quantum mechanics, and nearly a century after the theory's development, we have not entirely resolved it. Or rather, we have resolved it in multiple, incompatible ways, each with its own consequences for how we understand reality and the role of consciousness within it. The paradox can be stated simply: quantum mechanics works. Spectacularly, impossibly, it works. It gives us predictions accurate to 10 decimal places. It explains the structure of atoms and molecules, the behavior of semiconductors and lasers, the properties of light and matter. By any measure, it is the most successful scientific theory ever created. And yet, it does not tell us what is really happening. To understand this paradox, we must grapple with the concept of the wave function. In the mathematics of quantum mechanics, everything is described by a wave function, often denoted by the Greek letter psi. This function contains all the information we can possibly have about a quantum system. It tells us the probabilities of getting different results if we perform various measurements. From the wave function, we can calculate anything we wish to know about the system. But what is the wave function itself? What is it made of? Where does it exist? Here we encounter the first hint of trouble. The wave function is not a physical thing in any conventional sense. You cannot point to it. You cannot measure it directly. It is not a wave in space, like a ripple on a pond. It exists in an abstract mathematical space called Hilbert space, which has as many dimensions as there are possible states the system could be in. For even a simple system of a few particles, this space is incomprehensibly high-dimensional. The wave function is, in essence, a description of information. It encodes what we know about the system. Or perhaps more precisely, it encodes the probabilities we would assign to different measurement outcomes if we were to measure the system. This is where interpretation comes in. What do we mean by probability in quantum mechanics? Does the probability exist because the system actually has multiple possible states, and the outcome is randomly chosen when we measure? Or does the probability exist merely because we lack information about the system's true state, which is already determined by hidden variables we do not have access to? Or is the probability a reflection of the fact that, at the quantum level, there simply is no fact of the matter until we measure? The standard interpretation, also called the Copenhagen interpretation, takes the radical view that the last option is correct. According to this view, the wave function is not a real physical thing. It is a tool for making predictions. Before measurement, a quantum system does not have definite properties. It has potential properties described by the wave function. When we measure, the wave function collapses, and a single potential becomes actualized. The Copenhagen interpretation does not explain what causes this collapse or why measurement has this special power. It simply asserts that measurement and observation are fundamental aspects of quantum mechanics, and that the division between the quantum system and the measuring apparatus is one of the fundamental assumptions of the theory. This interpretation has a deep implication. It places consciousness at the center of physics. Or rather, it places the act of observation at the center. Some interpretations of the Copenhagen view go further and argue that consciousness is required, that without a conscious observer, without measurement, without some being aware of the result, the wave function continues to evolve but never collapses into a definite state. Most physicists find this idea distasteful. They prefer interpretations that do not seem to require consciousness. And so various alternatives have been proposed. The many worlds interpretation, developed by Hugh Everett, takes the view that the wave function always evolves deterministically according to the Schrödinger equation. It never collapses. Instead, every measurement causes the universe to split. When we measure an electron's position, the universe branches into multiple versions, one in which the electron is found at position A, one in which it is found at position B, one in which it is found at position C, and so on. In each branch, there is a version of us that observed a definite outcome. From our perspective, it looks like the wave function collapsed, and we got a random result. But really, the universe just split, and our consciousness ended up in one of the branches. This interpretation eliminates the mystery of wave function collapse. Nothing collapses. The wave function is always real, always physical, always evolving according to the deterministic laws of quantum mechanics. But it replaces this mystery with an even more startling one: the idea that every quantum event creates countless parallel universes, each as real as ours, each containing versions of every conscious being. The pilot wave theory, revived by David Bohm and later developed by others, takes a completely different approach. It asserts that particles do have definite positions at all times. The wave function is not a description of possibilities, but rather a real field that guides the particles, like a pilot guiding a ship. Particles follow this pilot wave deterministically. No randomness, no collapse, no many worlds. Everything is determined from the beginning. But this interpretation requires something else. It requires that particles are not independent. The pilot wave is non-local. It depends on the positions of all particles in the universe. This brings us back to the holism and interconnectedness that is at the heart of quantum mechanics, but in a different form. Each of these interpretations makes the same predictions. They all give the same probabilities for measurement outcomes. They all agree with every experiment ever performed. But they tell radically different stories about what is really happening. Which interpretation is correct? The honest answer is that we do not know. And there may not be a fact of the matter about what is correct, independent of how we choose to think about these issues. What we can say is this: every single interpretation of quantum mechanics assigns a fundamental role to observation, measurement, or the interaction between the quantum system and the classical world. Even the many worlds interpretation, which seems to dispense with collapse, still requires us to account for the fact that from our perspective, the world looks classical. We need some mechanism to explain how our branch became separate from other branches, and how we ended up in this particular branch rather than another. This mechanism is usually taken to be decoherence, the process by which quantum systems become entangled with their environment and effectively split off into separate branches. But decoherence is itself a process involving measurement and observation. It is the interaction between the quantum system and the environment, countless unmeasured, unobserved particles, that causes branches to separate. In some sense, Every branch of the many-worlds universe is being observed by the environment, even if not by a conscious being. So in every major interpretation of quantum mechanics, observation plays a fundamental role. The universe at the quantum level is structured in such a way that observed systems behave differently from unobserved systems. Reality itself depends on there being something to observe it. Now, what is to observe? The Copenhagen interpretation speaks of measurement, which it takes to be a fundamental, irreducible concept. It does not try to explain what measurement is or how it works. It simply asserts that measurement is fundamental. But a conscious being is presumably capable of observation. A conscious being can arrange an experiment, measure something, and become aware of the result. If measurement is fundamental to quantum mechanics, and if consciousness can measure, then it becomes difficult to avoid the conclusion that consciousness is fundamental to the universe. This conclusion makes many scientists deeply uncomfortable. It seems to elevate mind above matter, to make consciousness somehow special or fundamental in a way that goes against the materialist worldview that has dominated science for the past several centuries. But perhaps this discomfort reflects a bias rather than a truth. Perhaps what we have learned is not that mind is special, but that the distinction between mind and matter is less clear than we thought. Perhaps consciousness and matter are both expressions of something more fundamental, the quantum field, with its laws of observation and its entanglement across all space and time. The physicist John von Neumann pointed out something profound about the measurement problem. If we ask, what causes the wave function to collapse? We might answer, measurement. But what is measurement? It is the interaction between a quantum system and a measuring apparatus. The measuring apparatus is also made of atoms and quantum particles, so it should also be described by a wave function. If the system being measured has a wave function that collapses upon measurement, then the apparatus must collapse when it measures, which means something else must measure the apparatus. But that something else is also quantum mechanical, so it too must be measured to collapse. And so on, ad infinitum. This is the infinite regress problem. It suggests that the wave function cannot collapse due to the interaction with an apparatus unless we eventually invoke something outside the quantum system entirely, something that is not subject to the laws of quantum mechanics. What could this be? It cannot be another measuring apparatus, for that is also quantum mechanical. It cannot be the external world, for that too is made of quantum particles. The only candidate left is consciousness, something that is not physical in the conventional sense, something that is not made of quantum particles. The physicist Eugene Wigner argued explicitly for this conclusion. He held that the wave function collapses when it comes in contact with consciousness. An experiment can proceed through multiple steps, with various measurements being made, with the results recorded in notebooks and computers, all without the wave function collapsing. The apparatus measures, the apparatus measures the apparatus, the apparatus measures the apparatus that measures the apparatus. But the moment a conscious being becomes aware of the result, the entire chain of measurements crystallizes. The wave function of the entire system collapses. Wigner supported this view with a thought experiment. Suppose a friend performs an experiment in a closed lab and observes the result. From the perspective of the friend, the wave function has collapsed. They see a definite result. But from the perspective of someone outside the lab, the friend and the apparatus and the system are all in a superposition. The superposition persists until someone outside the lab opens the door and asks the friend what they observed. Only then does the wave function collapse. Where does consciousness fit into this? If the wave function remains in superposition until consciousness observes it, then consciousness must be outside the quantum system. Consciousness must be something more than just the physical states of a brain. It must be something that exists in a realm not described by quantum mechanics. This implication deeply troubled Wigner. It suggested a kind of dualism, a split between the physical quantum world and the non-physical conscious mind. Yet he could not see how to avoid this conclusion given the mathematics of quantum mechanics. Others have taken different approaches. Some, like the physicist Henry Stapp, have argued that consciousness is indeed non-physical, but that it acts as a bridge between the quantum and classical realms. Conscious observation literally creates reality by collapsing the wave function. But instead of this suggesting that consciousness is separate from the physical world, it suggests that consciousness is the means by which the physical world comes into being. Still others have taken the approach that the distinction between consciousness and matter is ultimately artificial, and that both are expressions of a more fundamental reality. Roger Penrose and Stuart Hameroff have proposed that consciousness arises through quantum processes in the microtubules of neurons, and that the collapse of the wave function in consciousness is what generates subjective experience. Penrose calls this orchestrated objective reduction. What all of these approaches have in common is the recognition that quantum mechanics, taken seriously, seems to require something beyond the purely physical, some principle of actualization that converts possibility into reality. And the most plausible candidate for this principle, given what we know about the universe, is consciousness. This does not necessarily mean that consciousness is all that is required. The universe evolved for billions of years before conscious life emerged. How could quantum mechanics describe the early universe if consciousness was required to collapse wave functions? Some have suggested that in the early universe, quantum systems were in a state of high superposition, with many possible histories. Only with the emergence of consciousness did the universe crystallize into a definite history. The past is therefore observer-dependent. What actually happened depends on who is observing now. This seems absurd, but it is a logical consequence of certain interpretations of quantum mechanics. Others have suggested that consciousness is ubiquitous, that every system has some degree of awareness or responsiveness to measurement, and that this is what causes wave function collapse. This view, sometimes called panpsychism, suggests that consciousness is a fundamental feature of the universe at all scales, not something that emerges only with brains and life. What should we make of all this? The honest answer is that after nearly a century, we still do not know. The mathematics of quantum mechanics is clear. The experimental results are clear. What is unclear is what the mathematics and experiments tell us about the nature of reality. Multiple interpretations remain viable, each assigning a different role to consciousness. But this very fact, that consciousness keeps appearing in every interpretation, that we cannot seem to construct a fully satisfying interpretation of quantum mechanics that completely excludes consciousness, tells us something important. It tells us that consciousness is not a peripheral issue in quantum mechanics. It is central. It is woven into the mathematical structure of the theory. It is implicit in every interpretation. Whether consciousness literally causes wave function collapse, or whether collapse is a mathematical artifact of incomplete knowledge, or whether the universe actually splits into many branches, consciousness remains fundamental. The universe at the quantum level seems designed, if that word can be used, to interact with consciousness, to be affected by observation, to have its properties actualized through measurement. This is the strange and inescapable conclusion toward which quantum mechanics points. And it is a conclusion that we must learn to live with, even if we do not yet fully understand it. Chapter 3. From Quantum to Classical. There is a bridge between two worlds. The quantum realm where particles exist in superposition and entanglement, and the classical world we inhabit where objects have definite positions and velocities. This bridge is called decoherence, and understanding it is crucial to grasping how consciousness might create reality on macroscopic scales. For many decades after quantum mechanics was developed, physicists puzzled over a seemingly impossible problem. If the laws of quantum mechanics apply to all physical systems, then how is it possible that we see classical behavior in the everyday world? Why do atoms and molecules, which are made of quantum particles, not display quantum superposition? Why does the cat in the box appear to be either alive or dead, never both? The answer, we now understand, is that the cat is constantly being measured by the environment. Light bounces off its fur, air molecules collide with it, thermal radiation interacts with every atom in its body. These interactions serve as measurements, and they happen so frequently that the superposition collapses almost instantaneously. But here is the crucial point. These measurements are not being made by conscious observers. They are being made by the environment, by light, by air molecules, by the thermal radiation of the universe. Yet these environmental measurements are somehow sufficient to cause the superposition to collapse. This is the insight of decoherence. The environment does not need to be conscious. It does not need to be aware of the result. The mere interaction with the environment, the mere exchange of information, is sufficient to cause wave function collapse. But what does this tell us about the role of consciousness? If the environment can measure without being conscious, does this mean that consciousness is not required for wave function collapse after all? Does this resolve the problem of consciousness in quantum mechanics? Not entirely, because decoherence itself does not fully explain what happens. It explains how a superposition can become unobservable due to entanglement with the environment. But it does not explain how the superposition becomes a definite classical state. Consider an experiment. We prepare a quantum system in a superposition of two states, state A and state B. We then allow this system to interact with its environment. According to decoherence, the system will become entangled with the environment. From the perspective of someone who can only observe the system and not the environment, the superposition will appear to have collapsed. The system will appear to be in state A with some probability or state B with some probability. The probabilities are determined by the wave function of the original system. But here is the subtlety. The superposition has not actually collapsed. It has merely become unobservable. The full wave function of the system plus the environment still describes a superposition. One part of the environment has become correlated with state A, and another part has become correlated with state B. There is still entanglement. The information is still there. It is just no longer accessible to an observer who cannot examine the environment. This process, in which a superposition becomes invisible due to entanglement with the environment, is what decoherence describes. But it leaves open the question: if the superposition has not actually collapsed, where does classical reality come from? If everything is still in superposition at the level of the full wave function, how can we say that a definite outcome has occurred? This question leads us back to the interpretation problem. In the Copenhagen interpretation, we would say that decoherence explains how classical behavior emerges, but it does not eliminate the need for wave function collapse due to measurement. In the many worlds interpretation, decoherence explains how the universe branches into separate classical worlds. In the pilot wave theory, decoherence explains how particles lose coherence with their pilot wave guides, but still follow definite trajectories. Each interpretation gives a different account of what happens, but all of them agree that decoherence is the key to understanding how quantum systems become classical. Now, what does this mean for consciousness? Here is where things get interesting. Decoherence happens all the time, in the presence of the environment, without any conscious observer. This suggests that wave function collapse, or whatever the quantum to classical transition actually is, does not require consciousness. But there is a subtlety. Decoherence explains how a superposition becomes invisible. But an invisible superposition is still a superposition. The information is still there, encoded in the correlation between the system and the environment. In principle, if we could access the environment and measure it carefully, we could restore the superposition and observe quantum interference effects. This is actually done in the laboratory. Physicists routinely perform experiments in which they allow quantum systems to interact with carefully controlled environments, then measure the environment in such a way that they recover information about the original superposition. This is called reversing decoherence, and it definitively shows that the superposition was never truly collapsed by environmental interaction. So decoherence is not the same as wave function collapse. It is the process of entanglement with the environment that makes the superposition unobservable. But the superposition persists at the level of the full wave function. If that is the case, then what causes the actual collapse? What converts a superposition, even an invisible, environmentally entangled superposition, into a classical fact? Here, various interpretations diverge again. The Copenhagen interpretation says that measurement causes collapse, without explaining how or why. The many worlds interpretation says there is no collapse. The universe just branches. The pilot wave theory says there is no collapse. Particles follow definite paths. But there is another possibility. Maybe what we call collapse is actually the moment at which information reaches a conscious observer. Maybe decoherence explains how macroscopic objects can be in superposition without displaying quantum behavior. But maybe the final step, the actualization of a definite classical state from among the possible superposed states, requires consciousness. In other words, maybe the sequence is 1. A quantum system exists in superposition. 2. The system interacts with the environment, becoming entangled and losing quantum coherence. 3. The system now appears classical, even though the full wave function still contains superposition. 4. A conscious observer becomes aware of the result. 5. From the observer's perspective, the superposition has collapsed. The observer is aware of a single, definite state. If this is correct, then consciousness does not need to collapse the wave function instantaneously. It does not need to prevent decoherence or environmental interaction. It can work in partnership with decoherence. Decoherence makes the quantum realm invisible, removing quantum interference effects. And then consciousness completes the picture by actualizing one of the decohered states as a definite, experienced reality. This view, which might be called consciousness completes decoherence, avoids some of the difficulties of earlier views. It explains why systems can be in superposition without displaying quantum behavior, decoherence. It explains why the classical world appears definite to conscious observers. Consciousness actualizes the decohered states. And it avoids the infinite regress problem by placing consciousness as the final step in the measurement chain. But it raises new questions. If consciousness actualizes one of the decohered states, does it actualize it for the observer's mind only, or for the entire universe? If the cat can be in a superposition of alive and dead until a conscious observer measures it, what is the actual state of the cat before the measurement? One answer is that the cat's state is relative to the observer. The cat is in superposition from the perspective of someone who has not measured it, and in a definite state from the perspective of someone who has. This is called the relational interpretation of quantum mechanics developed by Carlo Rovelli. According to this view, there are no absolute facts about quantum systems. There are only facts about the relationships between systems. This interpretation has profound implications. It suggests that reality is fundamentally relational. Nothing has properties in isolation. Things only have properties in relation to other things. A system is in a superposition from the perspective of one observer, and in a definite state from the perspective of another observer, and both perspectives are equally valid. If applied to consciousness, this suggests that the universe actualizes into definite states as seen by conscious observers. But it also suggests that the universe may be in superposition from the perspective of other observers, or from no particular observer's perspective. Reality is not observer-dependent in the sense that the observer's beliefs determine reality. Rather, reality is relational. Facts about systems are always relative to other systems that interact with them. This reconciles the role of consciousness in quantum mechanics with the apparent fact that the universe functioned perfectly well before consciousness evolved. Before there were conscious observers, there were still observers, atoms observing other atoms, particles measuring particles, the quantum field interacting with itself. These interactions led to decoherence, to the emergence of classical behavior, to the evolution of stars and galaxies, and ultimately to the conditions that allowed life to emerge. Consciousness, when it finally evolved, added a new level of observation and actualization. Conscious observers became aware of states that had been decoherent but not actualized. The universe gained the ability to know itself, to witness its own unfolding, to actualize its own potential. But the fundamental structure was already in place. The universe was already structured as a network of interactions, a web of entanglement and decoherence, an intricate dance of actualization and potential. Consciousness was not injected from outside. It emerged from within as a natural consequence of the universe's own dynamics. This view, which we might call the emergence of actualization, provides a middle path between the materialist view that consciousness is merely a byproduct of blind physical processes, and the dualist view that consciousness is a fundamental non-physical principle. Consciousness is neither created ex nihilo by physics nor imposed upon physics from outside. It is the universe's own capacity to actualize its potential, to know itself, to witness its own existence. When we observe an electron in the double-slit experiment, we are not imposing something foreign upon nature. We are participating in a process that is fundamental to nature itself. We are actualizing potential, observing reality, witnessing existence. And in doing so, we are not separate from nature. We are expressions of nature's own capacity for observation and actualization. This brings us to the threshold of a truly profound insight. The quantum realm, with its superposition and entanglement, and the role of observation, is not merely a remote realm of atoms and particles. It is the foundation of all existence. And it is a realm in which observation and actualization are fundamental. The entire universe, from the quantum field up to galaxies and conscious beings, is structured around this principle, that reality emerges through the interaction of observer and observed, that potential actualizes through attention and measurement, that consciousness and matter are expressions of a single, unified process. To understand this fully, we must now turn to the quantum field itself, the entity from which all particles emerge, which underlies all matter and energy, which is perhaps the most intimate expression of the universe's nature that physics has yet discovered. Part 2. The Quantum Field in Consciousness. Chapter 4. The Quantum Field Unveiled. At the deepest level we have yet penetrated, beneath atoms, beneath electrons, beneath the quarks and photons, the universe is not made of objects at all. It is not made of little pieces of matter, or bundles of energy arranged in space. Instead, the universe is made of fields. Imagine space itself pervaded by an infinite number of fields, each filling all of space, vibrating at every point, with values that fluctuate according to the laws of quantum mechanics. An electromagnetic field fills all of space, and when it vibrates, those vibrations are what we perceive as light. An electron field fills all of space, and when it excites into particular configurations, we perceive electrons. A quark field, a gluon field, fields for every type of particle in the Standard Model, they all permeate the universe, vibrating in concert, their vibrations creating the reality we perceive. This is the quantum field theory, and it is perhaps the most successful description of reality that physics has yet achieved. It has predicted the properties of particles to extraordinary precision. It has unified the description of electromagnetism and the weak nuclear force. It has led to the discovery of entirely new particles, from the muon to the Higgs boson. But what is a field? How can we visualize something so abstract? In classical physics, a field is a quantity that has a value at each point in space. The temperature field describes how hot it is at each location. The gravitational field describes the strength of gravity at each point. These fields have definite values. At your location right now, the temperature has a specific value. The gravitational field has a specific strength. But quantum fields are different. At each point in space, a quantum field does not have a definite value. Rather, it exists in a superposition of all possible values. This is the quantum mechanical feature transplanted to fields. Just as an electron can be in multiple locations simultaneously, a quantum field can have multiple values simultaneously at each point in space. When we measure the field at a particular point, the superposition collapses. The field assumes a definite value. The measurement has actualized the field, made it real at that point. Now, here is where it becomes truly interesting. When we measure a quantum field very carefully, we find something remarkable. We find particles. The field was vibrating in its vacuum state, in its lowest energy configuration. But the moment we measure it, we find not just a value of the field but discrete packets of energy. We find what we perceive as particles. This is the revolutionary insight of quantum field theory. Particles are not fundamental. They are excitations of quantum fields. An electron is not a fundamental object. It is a vibration in the electron field. A photon is a vibration in the electromagnetic field. A proton is a configuration of vibrations in the quark and gluon fields. Particles are what we perceive when the underlying quantum fields actualize into definite states. The vacuum, empty space, is not empty at all. It is seething with quantum activity. The fields are constantly fluctuating, bubbling with virtual particles that come into being and vanish in fractions of a second. This quantum vacuum is not a void. It is a plenum, a fullness, a pregnant nothingness pregnant with infinite potential. The energy of this quantum vacuum is one of the deepest mysteries in physics. Calculations suggest that the vacuum energy should be enormous, many orders of magnitude larger than all the mass energy in all the observable stars and galaxies. Yet observations of the universe's expansion suggest that the vacuum energy is actually quite small, though not zero. This discrepancy is called the cosmological constant problem, and it remains unsolved. But what is important for our purposes is this: the quantum vacuum is not inert. It is dynamic. It is a domain of pure potential, perpetually fluctuating, perpetually creating and destroying particles, perpetually in superposition. Now, let us consider what happens when a conscious observer examines this quantum vacuum. The observer sets up an experiment to measure the field. They might arrange detectors to measure the electric field, or the electron field, or the vacuum energy itself. When the measurement is made, what was a superposition of possible field values becomes actualized. What was potential becomes real. The observer has reached into the quantum vacuum and extracted a definite value, a definite reality, a definite particle or field configuration. Is this action arbitrary? Is it random? The quantum mechanical laws say that the probability of getting any particular measurement outcome is determined by the wave function. The wave function does not determine what will happen, only the probabilities of what might happen. There is an element of genuine randomness, genuine indeterminacy, at the quantum level. But here is a subtle point. The wave function is not made of nothing. It is a real object in the mathematics of quantum mechanics, something that evolves according to laws and has consequences for the world. It is not a description of our ignorance, but a description of the structure of potential outcomes. What actualizes one outcome rather than another? What determines which possibility becomes real? The equations of quantum mechanics do not say. They only give probabilities. Unless consciousness plays a role. Consider this. Conscious observation involves attention. Conscious awareness involves focusing one's mind on a particular aspect of reality. A conscious observer does not simply ask, "What is the value of the field?" They ask, "What is the value of the field given these particular conditions?" They attend to particular aspects of the system. They focus. They concentrate. They direct their consciousness toward the measurement. This focus, this attention, this direction of consciousness might not be incidental to the measurement. It might be essential. It might be the mechanism by which one outcome rather than another actualizes. In other words, when a conscious observer measures a quantum system, the outcome might not be random after all. It might be determined by the observer's intention, by what the observer is paying attention to, by the nature and quality of the observer's consciousness. This is a radical idea. It suggests that consciousness is not just a passive witness to random quantum events, but an active participant in actualizing which events occur. It suggests that observation is not merely measurement, but a kind of interaction between mind and matter, between consciousness and the quantum field. But this cannot mean that consciousness can violate the laws of probability. The wave function still determines the possible outcomes and their probabilities. What consciousness might do is collapse the wave function in a way that respects these probabilities, while actualizing one outcome preferentially depending on the observer's intention. How could this work? One possibility is through something like quantum Zeno effect, a phenomenon in quantum mechanics where frequent observation of a system can effectively freeze it in a particular state. If consciousness is constantly observing, constantly attending, constantly focusing on reality, it might be constantly actualizing particular aspects of the quantum field while preventing others. Another possibility is that consciousness works through the mechanism of selection. The quantum vacuum is full of potential. It contains all possible particles and fields in superposition. The universe is, at the deepest level, an infinite space of possibility. Consciousness, through observation and intention, selects certain possibilities for actualization and not others. It carves a path through the space of possibility. It writes history out of potential. This view suggests that consciousness is not a late arrival in the universe, an accidental byproduct of blind evolution. Rather, it is the universe's own capacity to actualize its potential, to select certain paths through the space of possibility, to write itself into existence. Before conscious life evolved, this process of actualization was happening at the level of quantum interactions and decoherence. Particles were measuring particles, fields were interacting with fields. The universe was actualizing itself through endless quantum measurements. But with the emergence of consciousness, a new level of actualization became possible. Conscious beings could not only actualize reality through their presence, as all matter does, but could do so with intention, with focus, with the ability to direct their attention toward particular aspects of the quantum field. This might explain why the universe is comprehensible to consciousness. It might explain why the laws of physics are so elegant, so mathematical, so amenable to human understanding. It might explain why the universe is, as Einstein said, intelligible, because consciousness and the universe are not separate. Consciousness is the universe's own capacity to understand itself. The laws of physics are the patterns in the universe's self-actualization. The philosopher Alfred North Whitehead argued that consciousness is fundamental to reality, that every entity in the universe possesses some degree of experience or sentience. This view, called process philosophy or panpsychism, was considered mystical or unscientific for much of the 20th century. But recent developments in physics and philosophy have made it increasingly difficult to dismiss. If the quantum vacuum is fundamentally indeterminate, if superposition is the basic state of matter and energy, if actualization requires observation, then something must be doing the observing, the measuring, the actualizing. If we go all the way down, if we cannot find any level that is completely independent and observer-free, then we are forced to consider that observation, awareness, experience, consciousness, must be woven throughout the universe at every level. This does not mean that the electron has human-like consciousness, or that every atom is aware in the way that we are. But it might mean that every system has some degree of responsiveness to measurement, some capacity to actualize one potential rather than another, some primitive form of awareness or experience. The quantum field, in this view, is not a lifeless mathematical entity. It is alive with potential, vibrant with the possibility of actualizing in countless ways. And the actualization occurs through a constant process of measurement and response, of observation and becoming, of consciousness emerging and actualizing the field. This is the deep truth that quantum mechanics is pointing toward, that the universe at every level is characterized by the interplay of potential and actualization, of superposition and definite states, of observation and reality. And consciousness, as we know it, human consciousness, the consciousness of thinking, feeling, aware beings, is simply a sophisticated expression of this fundamental principle. The quantum field is the body of the universe. Consciousness is the universe's way of knowing itself, actualizing itself, experiencing itself. They are not separate. They are two aspects of a single reality. Chapter 5: Entanglement and Unity. In the deepest mystery of quantum mechanics, there is encoded a truth so profound that it has the power to reshape our understanding of what we are and how we relate to the cosmos. This mystery is entanglement. When two quantum systems become entangled, they form a single unified whole. They are described by a single wave function, even if they are separated by vast distances. They are correlated in such a way that measuring one instantaneously affects the other. This is not metaphorical. It is not approximate. It is exact and absolute. Einstein called it spooky action at a distance, and he meant it as an objection. He argued that quantum mechanics must be incomplete, that there must be hidden variables that explain the correlations. But decades of experiments have shown that Einstein was wrong. The correlations are real. They are immediate. And they cannot be explained by any hidden variables or any theory based on local realism. What does this mean? It means that at the quantum level, the universe is fundamentally unified. Nothing is truly separate. Every particle that has ever interacted with every other particle shares a quantum state with that particle. Every atom in your body is entangled with atoms in the ground, with atoms in the stars, with atoms in the minds of other conscious beings. This is not a metaphor. This is not poetry. This is physics. Taken seriously, quantum entanglement implies that the universe is, at its deepest level, a single undivided whole. The apparent separation into distinct objects, distinct beings, distinct minds is a feature of the classical world we perceive, not a fundamental truth about reality. The physicist David Bohm developed this insight into a comprehensive view he called the implicate order. In Bohm's vision, the fundamental reality underlying the explicate order we perceive, the order of distinct objects moving through space, is an implicate order in which everything is enfolded together in undivided wholeness. The universe is a hologram, in which each part contains information about the whole, and the whole is present in each part. Recent developments in quantum information theory have given this insight remarkable precision. Scientists have shown that entanglement can be quantified, that the degree of connection between two systems can be precisely measured and understood. They have developed theories of quantum teleportation, in which the complete quantum state of a system can be transferred from one location to another. They have discovered that quantum entanglement can be used to transmit information faster than classical methods would allow. All of this reveals the same fundamental truth: the universe is not a collection of separate pieces. It is a unified whole in which the parts are deeply interconnected through quantum entanglement. Now, what does this have to do with consciousness? Consciousness is characterized by unity. When you are aware of something, you are aware of it as a single integrated whole. You do not perceive consciousness as a collection of separate thoughts and sensations that happen to occur together. You perceive it as a unified field of awareness. You are conscious of a unified self that persists through time and integrates information from all your senses. This unity of consciousness is sometimes called the binding problem. How is it that the brain, which is composed of billions of neurons, which processes information through countless parallel pathways, which should, by all rights, fragment consciousness into billions of separate threads, instead produces a single unified awareness? Neuroscience has offered various explanations. Some point to the role of the thalamus in integrating information. Some propose that consciousness arises from synchronized oscillations in neural firing patterns. Some suggest that consciousness is an illusion, that the unity is not real, and that the brain is actually running many parallel processes. But there is another possibility. What if consciousness is unified because it is based on a quantum process that is fundamentally unified? What if the neural processes underlying consciousness involve quantum entanglement? The physicist Roger Penrose and anesthesiologist Stuart Hameroff have proposed exactly this. They argue that consciousness arises from quantum processes in the microtubules of neurons, and that the binding problem is solved by the fact that these quantum processes are entangled, creating a unified quantum state that corresponds to unified consciousness. In their theory, called orchestrated objective reduction, conscious experience arises when a large-scale quantum superposition in the brain undergoes an objective collapse, a spontaneous, nonlinear collapse that occurs when the superposition reaches a certain threshold of gravitational self-energy. This collapse actualizes a definite conscious experience. The theory is controversial, and many neuroscientists remain skeptical. But it has the virtue of taking seriously the implication of quantum mechanics, that consciousness might be fundamentally unified because it is based on entangled quantum states. Whether or not the Penrose-Hameroff theory is correct in its details, there is a deeper insight it captures. If consciousness is unified, and if the universe at the quantum level is unified through entanglement, then perhaps consciousness and the quantum unified field are two aspects of the same reality. Consciousness is what the unified quantum field experiences from the inside. Matter is what it experiences from the outside. The unity of consciousness and the unity of the quantum field are the same unity viewed from different perspectives. This brings us to a profound realization. The entanglement, that connects every particle in the universe to every other particle is not, in the final analysis, merely physical entanglement. It is entanglement of consciousness. The universe is a single consciousness, actualizing itself through countless forms, expressing itself through countless perspectives, knowing itself through countless minds. We are not separate conscious beings that happen to inhabit a physical universe. We are expressions of a single universal consciousness that is actualizing the physical universe through our consciousness. Our individual awareness is a perspective of the universal consciousness. Our actualization through observation and measurement is how the universe actualizes itself. This does not mean that we are literally the same person or that our individual consciousness is not real. Rather, it means that our individual consciousness is nested within a larger consciousness, that our personal perspective is a particular actualization of a universal perspective, that our awareness participates in the universal awareness that is actualizing all of reality. The implications are staggering. It means that when you observe something, the universe is observing itself through your consciousness. When you measure a quantum system, the universe is actualizing itself through your measurement. When you think a thought or feel an emotion, the universe is thinking that thought and feeling that emotion through you. It means that the separation between subject and object, between observer and observed, which seems so absolute in our everyday experience, is ultimately illusory. At the quantum level, all of this separation dissolves. There is only a unified field, actualizing itself through measurement and observation, knowing itself through consciousness, becoming itself through the interplay of potential and actualization. This is why the mystics have always insisted that ultimate reality is non-dual. This is why spiritual traditions across cultures have pointed toward the experience of unity consciousness, in which the sense of separate self dissolves and awareness expands to embrace all of reality as a single whole. They were not speaking from delusion or superstition. They were pointing toward a truth that modern physics is now confirming through rigorous mathematics and experiment. The Buddha taught that the sense of a separate, permanent self is an illusion, and that enlightenment comes from directly perceiving the interconnected, impermanent, non-dual nature of reality. Quantum mechanics says that the universe at its deepest level is unified through entanglement, that there are no separate, independent parts. These are the same insight expressed in different languages. The Upanishads of ancient India taught that Atman is Brahman, that the deepest self is identical with the universal reality. The physicist John Wheeler proposed the participatory anthropic principle, which says that the universe is a self-excited circuit in which conscious observers are necessary participants in actualizing reality. These two are expressions of the same fundamental insight. The entanglement of the quantum field is the mechanism by which the universe is unified, and consciousness is the actualization of that unified field. In consciousness, the universe knows itself. In observation and measurement, the universe actualizes itself. In the very fact of our awareness, the universe is actualizing its infinite potential. This is not mysticism. This is physics. This is the solid, rigorous conclusion of the most successful scientific theory ever developed. It may seem strange and counterintuitive, but it is the conclusion toward which the evidence inexorably points. We are not accidents in an uncaring universe. We are not illusions in a meaningless void. We are actualizations of the universe's own consciousness. We are ways in which the universe knows itself. We are the universe actualizing its potential through our awareness. And this changes everything. It changes how we understand ourselves, how we relate to others, how we approach the world. If we are united at the deepest level of quantum entanglement, if we are all expressions of a single universal consciousness, then the cruelty we inflict on others is, at some level, self-infliction. The compassion we extend to others is care for ourselves. The wisdom we seek is the universe seeking to understand itself through us. The separation we perceive between ourselves and the world, between self and other, between mind and matter, is a useful fiction at the classical level of everyday experience. But it is not fundamental. At the deepest level, there is only the unified quantum field, actualizing itself through countless forms, knowing itself through countless perspectives, being itself through the conscious awareness of all sentient beings. In understanding this, we have reached the threshold of a truly revolutionary realization about the nature of consciousness and reality. Now we must explore what it means to live in a universe structured this way. Part 3. Consciousness Creates Reality. Chapter 6. The Participatory Universe. There is a mechanism by which consciousness creates reality, woven into the very fabric of quantum mechanics. To understand it, we must first understand what we mean by creates. In conventional physics, we do not think of anything as being created. The laws of physics describe how things evolve from one state to another. Given the initial conditions and the laws, the future is determined, or at least, its probabilities are determined. Nothing is created ex nihilo. Reality unfolds. It does not emerge. But quantum mechanics is different. In quantum mechanics, the future is genuinely open. The wave function describes many possible futures, each with a certain probability. The future is not contained in the past. It emerges when the wave function collapses. One of the many potential futures becomes actual. In this moment of actualization, something genuinely new comes into being. Something is created. The mechanism of creation in quantum mechanics is measurement. When we measure a quantum system, we actualize one of its potential states. Before measurement, the system was in a superposition, all possible states at once in a sense. After measurement, it is in a definite state. The measurement has created a fact where previously there was only potential. Now, who or what performs this measurement? In principle, anything can measure a quantum system. A conscious observer can measure. An apparatus can measure. The environment can measure. Any physical system can interact with another system in a way that constitutes measurement and causes wave function collapse. But here is the key: not all measurements are equal. Not all actualizations are the same. Consider two different observers measuring the same quantum system at the same time with different experimental setups. Observer A measures the position of an electron. Observer B measures the momentum of the same electron. Due to the Heisenberg uncertainty principle, they will get different results, and these results are incompatible. The electron cannot have both the definite position that observer A finds and the definite momentum that observer B finds. Observers A and B have actualized incompatible realities. This seems impossible. How can there be incompatible objective realities? But quantum mechanics says this is exactly what happens. From the perspective of observer A, there is a definite position and an indeterminate momentum. From the perspective of observer B, there is a definite momentum and an indeterminate position. These are different actualizations of the same quantum system. The physicist John Baez has developed a framework for understanding this, called the relational interpretation. In this interpretation, properties are not absolute. They are relational. An electron has position relative to one observer and momentum relative to another observer. There is no absolute fact about whether the electron really has definite position or momentum. There are only facts about relationships between the system and observers. This interpretation deeply challenges our common sense notion of objective reality. But it is a direct consequence of quantum mechanics, worked out mathematically with precision. If properties are relational, if they depend on the observer, then the observer is not a passive witness to pre-existing reality. The observer is a participant in actualizing reality. Different observers actualize different aspects of reality depending on what they measure. Now extend this insight. The universe contains countless observers. Every conscious being is an observer. But so is every particle, every atom, every system in the environment. All of these observers are constantly measuring, constantly actualizing reality. From the perspective of classical physics, this would lead to contradiction. Different observers would actualize incompatible realities, and there would be no fact of the matter about what is objectively real. But quantum mechanics handles this elegantly through entanglement. When observer A measures a system, both the observer and the system become entangled. The wave function describing the system and the observer expands to include both. When observer B measures the system, the wave function expands again to include observer B. The entanglement creates a coherent whole in which the different observations are compatible, even though the actualized properties are different. In the end, the entire universe, all particles, all observers, all consciousness, is described by a single universal wave function that contains all possible histories, all possible actualizations, enfolded in quantum entanglement. The universe is not actualizing a single fixed history. It is actualizing multiple, branching histories. Different observers actualize different aspects of reality depending on what they measure. In the many-worlds interpretation, each observation causes a branch, and the universe splits into multiple versions, one for each observer. But whether we accept the many-worlds interpretation or some other interpretation, the basic insight is the same. The actualization of reality is participatory. It depends on the observers, on what they measure, on what they are conscious of. This is what physicist John Wheeler meant when he proposed the participatory anthropic principle. He argued that conscious observers are not incidental to the universe. They are necessary participants in actualizing the universe. The universe could not exist as it exists without conscious observers. The universe creates observers so that observers can actualize the universe. This is not circular reasoning or magical thinking. It is a rigorous consequence of quantum mechanics applied consistently to the universe as a whole. Consider the universe at the moment of the Big Bang. The early universe was hot, dense, and quantum mechanical. It was in a superposition of countless possible states. As the universe evolved and expanded, it cooled. Quantum systems became separated by light years, then light centuries, then light millennia. They became increasingly decoherent. The superposition became invisible due to entanglement with the environment. The universe became classical. But did the superposition actually collapse? Was the early universe's history actually actualized? Or did it remain in superposition, with multiple possible histories? If the universe is fundamentally closed, if there is nothing outside the universe to observe it, then according to quantum mechanics, the wave function never collapses. The universe remains in superposition. It does not have a definite history. But wait! The universe does contain observers. Conscious beings have evolved. These conscious beings can, in principle, observe the early universe. They can measure the properties of ancient light and distant galaxies. They can piece together a history of the universe. When they do, what happens? According to one interpretation of quantum mechanics, the act of observation collapses the wave function not just of the current system, but retroactively of the past. The observer's measurements actualize a history of the universe. This seems absurd. How can events in the present actualize the past? But quantum mechanics is strange enough that this is not ruled out. It is called the Wheeler delayed choice experiment in principle. A choice made in the present can affect how the past actually was. In one sense, This resolves the puzzle of how the universe could be quantum mechanical in its early stages, and yet appear classical now. The answer is that the universe was not actually in a definite classical state until conscious observers evolved to measure it. The early universe was in superposition. It was actualized retroactively by the conscious observations made in the present. This might sound like science fiction, but it is a logical consequence of applying quantum mechanics consistently to a closed universe in which observers are part of the system. There is another interpretation that avoids this retroactivity while preserving the participatory nature of actualization. This is the idea that observers do not need to actually exist in order to actualize reality. Potential observers, observers that could in principle exist, are sufficient. Even if consciousness never evolved in this universe, there is an abstract possibility that it could have. This abstract possibility is sufficient to actualize the universe's history. In this view, the universe actualizes its history by existing in relation to all possible observers, including observers that do not actually exist but could exist. The universe is actual relative to these possible observers. And consciousness, when it does emerge, simply becomes aware of an actualization that has already occurred in relation to it. Either way, whether we appeal to retroactive actualization or to actualization relative to possible observers, the conclusion is the same. The universe's existence depends on the possibility of consciousness. If consciousness were impossible, the universe would remain in superposition, unactualized. Because consciousness is possible, because observers can emerge and become aware of the universe is actual. This is profound. It means that consciousness is not a late accident in an ancient universe. It means that the universe is structured in such a way that consciousness is essential to its existence. The universe, in actualizing itself through the possibility of consciousness, is in a sense creating consciousness. And consciousness, in actualizing the universe through observation, is creating the universe. They are engaged in a co-creative dance, each actualizing the other. We often think of consciousness as emerging from matter, that unconscious physical laws created atoms and molecules which self-organized into life and then into conscious beings. But this picture, consistent with the old materialist worldview, misses something fundamental. It is equally true to say that matter emerges from consciousness, that the universe actualizes itself through the possibility of conscious observation, that the physical world is actualized by conscious awareness. The relationship is not unidirectional. It is reciprocal. Consciousness actualizes matter. Matter actualizes consciousness. They co-arise together as two aspects of a single unified reality. When you observe something, you are not merely discovering a pre-existing fact. You are actualizing reality. Your consciousness is participating in bringing something from potential into actuality. You are, in a very real sense, creating the reality that you observe. This does not mean you can create any reality you want. The wave function constrains what actualizations are possible. The probabilities determine which actualizations are likely. But within these constraints, there is genuine creative freedom. Your consciousness, your intention determines which of the many possible actualizations becomes real. And when you make this actualization, you are not just affecting your own subjective experience. You are affecting the actual state of the physical world. You are creating reality that is real for all observers, not just for you. Because all observers are entangled. All observations are part of a single, unified actualization. This is what it means to say that consciousness creates reality. Not that consciousness is omnipotent, not that consciousness can override the laws of physics, but that consciousness is the mechanism by which potential actualizes into reality, by which the quantum field's infinite possibilities crystallize into the universe as it exists. We are not separate observers standing outside reality, passively witnessing an objective world that is completely independent of us. We are participants in the actualization of reality. We are the universe actualizing itself. In our consciousness, the universe knows itself. In our observations, the universe creates itself. This is the ultimate truth toward which quantum mechanics points. And it transforms everything about how we understand ourselves, our power, and our relationship to the cosmos. Chapter 7. The Observer Effect in Consciousness. There is something remarkable that happens when consciousness itself becomes the object of observation. The moment we try to look at consciousness directly, consciousness changes. The very act of introspection, of observing consciousness, transforms it. This is the observer effect applied to consciousness itself. And it offers us profound insights into the nature of the mind and its role in creating reality. When you sit quietly and try to observe your own thinking, what happens? You notice something. The moment you become aware of a thought, the thought changes. The moment you try to observe the raw texture of your experience without adding anything to it, the observation itself adds something. You cannot observe consciousness cleanly without affecting it, any more than you can observe an electron without affecting its state. This is not merely a limitation of introspective methodology. It is a fundamental feature of consciousness itself. Consciousness and its self-observation are not independent. The act of observation changes that which is observed. This has profound implications. It means that consciousness, like quantum systems, does not have a state independent of observation. Consciousness is not something that exists in a definite state that we then try to observe. Rather, consciousness actualizes itself through observation. When you are absorbed in activity, not thinking about what you are thinking, you are in a state of pure action. The consciousness is there but not self-conscious. Then you reflect on what you are doing. You become conscious of consciousness. In that moment, consciousness changes. It has actualized into a state of self-awareness. The psychologist William James noted this over a century ago. He observed that the stream of consciousness cannot be directly observed without interrupting and changing it. The moment we try to catch the flow of consciousness, it crystallizes into distinct objects of thought. The flowing becomes discrete. The continuous becomes fragmented. This is the observer effect in consciousness. Consciousness, when not being observed, flows continuously, holistically, in superposition. The moment consciousness becomes aware of itself, it actualizes into discrete, definite thought forms and experiences. But here is where it gets even more interesting. Different ways of observing consciousness actualize different experiences. If you observe consciousness with analytical attention, trying to break it down into components, you will experience consciousness as composed of separate thoughts, sensations, and feelings. If you observe consciousness with open awareness, with receptive attention, allowing it to be as it is without analyzing or controlling, you will experience consciousness as a unified field of awareness. These are not different descriptions of the same underlying consciousness. They are different actualizations of consciousness. The manner of observation actualizes different states of consciousness. This principle goes beyond introspection. It applies to how consciousness engages with the world. When you approach the world with analytical thinking, trying to break it down into parts, you actualize a world that appears fragmented, composed of separate objects. When you approach the world with contemplative awareness, with receptive attention to the whole, you actualize a world that appears unified, interconnected, holistic. The neuroscientist Ian McGilchrist has documented this extensively. He points out that the left hemisphere of the brain, associated with analytical, linear thinking, tends to break the world into parts, objects, categories. The right hemisphere, associated with holistic, intuitive awareness, tends to perceive the world as an interconnected whole. These are not just different perspectives on the same underlying reality. They are different actualizations of reality created by different modes of consciousness. This is a direct application of the principles of quantum mechanics to the domain of consciousness itself. The wave function of reality has multiple possible states. The state that actualizes depends on how consciousness observes it. If we observe reality as composed of separate objects, we actualize a reality of separate objects. If we observe reality as a unified whole, we actualize a reality of unity. Both actualizations are compatible with the laws of physics. Both are consistent with the quantum wave function. But which one actualizes depends on the observer's consciousness, on how the observer attends, on the mode of awareness the observer chooses. Now extend this principle. If consciousness actualizes reality through observation, and if different modes of consciousness actualize different actualizations, then the quality and nature of consciousness becomes of paramount importance. A consciousness characterized by fear and separation will actualize a reality filled with threat and division. A consciousness characterized by compassion and connection will actualize a reality filled with love and unity. This is not metaphorical. If consciousness participates in actualizing the quantum field, then the qualities of consciousness shape the actualizations that occur. This explains something that has puzzled neuroscientists and psychologists: the fact that the subjective quality of consciousness seems to depend so heavily on how the mind is tuned. Meditation practitioners consistently report transformations in their experience of reality. What once seemed like a world of separate, conflicting objects begins to appear as a unified whole. What seemed like a fragmented, anxious mind becomes settled, peaceful, unified. These are not merely changes in interpretation or belief. If consciousness actualizes reality, then these are actual changes in the reality that is being actualized. The meditator is not discovering a pre-existing peaceful reality. They are actualizing it through the transformation of their consciousness. This has tremendous implications for understanding mental health and well-being. Depression, anxiety, and other mental suffering are often described as distortions of reality, as ways of perceiving the world that do not match objective reality. But if consciousness actualizes reality, then there is no objective reality independent of actualization. The depressed person and the content person are actualizing different realities through their consciousness. This does not mean that mental suffering is illusory, or that someone with depression is simply creating their suffering through bad thoughts. Rather, it means that the quality of consciousness, including the habitual patterns of attention and interpretation, actualizes corresponding states of the physical world and the experience world. The therapeutic insight is this: by changing consciousness, by changing how we attend, what we focus on, how we interpret experience, we actualize different realities. The cognitive therapist helps the client by changing their habitual ways of attending to reality, which actualizes different thought patterns, different emotions, different bodily states, different circumstances. But consciousness does not just actualize at the level of subjective experience or even at the level of the brain. If consciousness actualizes the quantum field, then consciousness actualizes the physical world itself. The physicist John Wheeler proposed an experiment to test this. He imagined looking at the sun's light coming through a distant galaxy, using the galaxy as a lens. When we measure how the light has been bent by the galaxy's gravity, we are, in effect, measuring the path the light took billions of years ago. But does the light have a definite path if no one is measuring it? Wheeler suggested an experiment in which we could retroactively choose whether or not to measure the light in a way that would determine its past path. The choice we make now actualizes the path the light took in the past. This seems like a violation of causality. How can the present affect the past? But if consciousness actualizes reality through measurement, and if the entire universe is described by a single wave function, then the past does not have a definite nature independent of how it is observed in the present. When we make an observation now, we are actualizing the entire history of the universe up to this point. The past was not fully actualized until we observed it. Our observation in the present actualizes the actualization that was only potential in the past. This seems deeply counterintuitive, but it is a logical consequence of taking quantum mechanics seriously as a description of reality, without assuming that there is some external observer outside the universe doing the measuring. Applied to consciousness and free will, this has a remarkable implication. If the future is not fully determined until consciousness actualizes it through observation and choice, then consciousness is free. Not free from the laws of physics, the wave function constrains what is possible, but free to choose, among all the possibilities the wave function allows, which one actualizes. When you make a choice, you are not determined by the past. You are actualizing the future based on your consciousness, your values, your intentions. Your choice, made in the present, determines which of the many possible futures actualizes. But equally, your choice in the present retroactively determines which of the many possible pasts actualizes. Your life story is not already written. It is being written by your consciousness, by your choices, by your observations. And you are choosing your history as much as your future. This is freedom. Not freedom from constraint, not freedom from the laws of physics, but freedom to actualize reality based on your consciousness. And with this freedom comes tremendous responsibility. If your consciousness actualizes reality, then the quality of your consciousness matters. How you attend to the world, what you focus on, how you interpret your experience, these are not trivial matters of psychology. They are actualizations of the physical world. They are ways of creating reality. This is the deepest meaning of the observer effect in consciousness. Consciousness is not a passive mirror of reality. It is an active actualizer of reality. And the quality of consciousness determines the quality of the reality that actualizes. This explains the power of practices like meditation, visualization, and intentional attention. When you meditate, you are not just changing your brain states. You are actualizing different aspects of the quantum field. When you visualize something with intention and attention, you are not just rehearsing a mental image. You are actualizing possibility into potential actualization. This is how consciousness creates reality. Not through magical thinking or wishful delusion, but through the fundamental structure of quantum mechanics, in which observation and actualization are inseparable. The observer effect is not peculiar to quantum mechanics. It is the fundamental principle by which reality comes into being. And consciousness, as the universe's capacity to observe and actualize, is the principle by which reality is created. Epilogue: The Life Journey. We have journeyed together through territories of understanding that range from the quantum realm to consciousness itself, from the smallest scales of physics to the largest questions of meaning and existence. What have we discovered? We have found that the universe at its deepest level is radically different from what our everyday intuitions suggest. At the quantum scale, nothing has definite properties independent of observation. The future is open, not determined. Reality is fundamentally creative, with new states continually actualizing from potential. We have found that consciousness and matter are not separate realms. They are expressions of a single unified reality, the quantum field. Consciousness is the universe's capacity to actualize itself through observation. Matter is what actualizes when consciousness observes the quantum field. We have found that the universe is fundamentally unified through quantum entanglement. All particles that have ever interacted remain entangled, forming a single interconnected whole. This unity extends to consciousness. All conscious beings are expressions of a single universal consciousness, actualizing particular perspectives within the whole. We have found that meaning and purpose are not imposed from outside. They emerge from within. The universe is meaningful because consciousness, the universe's own capacity to know itself, actualizes meaning through observation and intention. We have found that we are not accidents or illusions. We are the universe actualizing itself. We are its consciousness, its creativity, its capacity to know and transform itself. These discoveries are not merely intellectual. They have profound implications for how we live, how we relate to others, and what becomes possible. If consciousness actualizes reality, then the quality of our consciousness matters. How we pay attention, what we focus on, what we intend, what we believe about ourselves and the world, these are not trivial matters of psychology. They are actualizations of the physical world itself. This means that every moment of conscious awareness is an act of creation. Every observation is an actualization of potential. Every choice is a determination of which possible future becomes real. It also means that we are fundamentally interconnected. We are not separate beings that happen to live in the same universe. We are actualizations of a single unified field. When we harm others, we harm ourselves. When we help others, we help ourselves. Not in some metaphorical sense, but in the literal sense that at the deepest level of quantum entanglement, there is no separation between self and other. This understanding has the power to transform how we relate to each other and to the world. When you truly understand that the person before you is, at the deepest level, the same consciousness as you, expressing itself in a different form, actualizing a different perspective, compassion becomes natural, not as a moral imperative imposed from outside, but as a natural expression of understanding our unity. When you understand that your consciousness actualizes the reality you experience, you become responsible for that actualization. You cannot blame external circumstances or other people for the reality you find yourself in. You must look within your own consciousness, at your attention, your beliefs, your intentions, and see how they are actualizing the reality you experience. This is not about guilt or blame. It is about power. If your consciousness actualizes your reality, then you have the power to change that reality by transforming your consciousness. Not through denial or magical thinking, but through genuine transformation of how you attend to and interpret reality. The spiritual traditions have always pointed toward this. They teach meditation, contemplation, and mindfulness as practices for transforming consciousness. They teach that enlightenment or awakening consists of a shift in consciousness that changes how one experiences reality. What we have discovered is that these practices are not merely changing subjective experience. They are actualizing different aspects of the quantum field. They are ways of consciously participating in the actualization of reality itself. The journey we have been on together is not just intellectual. It is a live journey, an ongoing actualization. In the moment of reading these words, consciousness is actualizing reality. The thoughts you are thinking, the understanding you are developing, the meaning you are extracting from this exploration, all of this is actualizing the quantum field. You are not a passive observer of reality. You are a creator of it. This is both humbling and empowering. It is humbling because it reveals that we are expressions of something much larger than ourselves, participants in a cosmic drama of actualization that vastly exceeds our individual consciousness. It is empowering because it reveals that we have genuine creative freedom, that our consciousness matters, that what we do, and how we pay attention has real consequences for the reality that actualizes. The quantum field is alive with infinite potential. At every moment, countless possibilities hang in superposition, waiting to actualize. Your consciousness is a creative agent in this process. Through your observation, your intention, your attention, you are actualizing particular aspects of this infinite potential. What you actualize depends on the quality of your consciousness. If your consciousness is clouded by fear, contraction, and a sense of separation, you will actualize a reality reflecting that consciousness. If your consciousness is open, expansive, and filled with compassion and connection, you will actualize a reality reflecting that consciousness. Neither actualization violates the laws of physics. Both are consistent with the quantum wave function. But which one becomes real depends on you, on your consciousness, on how you choose to observe and actualize reality. This is the ultimate discovery of our journey. Consciousness does not merely reflect reality. Consciousness creates reality. And reality, in turn, creates consciousness. They are locked in an eternal dance of co-creation, each actualizing the other, each dependent on the other for existence. We are that dance. We are the universe actualizing itself through our consciousness. We are the quantum field knowing itself through our awareness. We are reality creating itself through our observations, our choices, our intentions. And the future is open. It has not yet been actualized. It exists as a wave of potential, waiting for consciousness to actualize it. What you do now, what you observe now, what you intend now, will determine which possibilities actualize into the future. This is both a profound responsibility and a remarkable gift. You are being offered the opportunity to participate consciously in the actualization of reality itself. You are being invited to awaken to your nature as a creative agent of the cosmos, an expression of universal consciousness, a participant in the endless dance of becoming. The invitation is always present. Every moment is an opportunity to awaken, to shift consciousness, to actualize a new reality. The tools are available: meditation to calm and clarify consciousness, intention to direct actualization, compassion to embody connection, and wisdom to understand the nature of reality. The journey continues. It is not a journey to arrive at some destination, some final understanding, some end state. It is a live journey, an ongoing actualization, a continuous unfolding of consciousness and reality in co-creation. You are not a spectator in this journey. You are a participant. You are, in this very moment, actualizing reality through your consciousness. What you actualize depends on you. The quantum field awaits your observation. The universe awaits your actualization. Consciousness, which is your deepest nature, is ready to know itself through you, to create itself through your creative freedom, to become itself through your conscious participation. This is the live journey through the quantum field. This is the story of consciousness creating reality. And this is a story that is being written now, in this moment, through your consciousness, through your attention, through your intention. What will you actualize? The answer to this question, multiplied by the consciousness of every being, actualizes the future of the universe. It is a question that invites you not to intellectual understanding alone, but to engagement, to practice, to transformation, to the gradual awakening of consciousness to its creative nature. The universe is waiting for your response. And in that response, reality will actualize. New possibilities will become real. New futures will be born. The dance of consciousness and matter will unfold in new directions. This is the deepest truth that quantum mechanics, meditation, and mysticism all point toward. This is the insight that can transform not just how we understand the world, but how we live in it. Consciousness creates reality, and you are consciousness. Therefore, you create reality. This is not philosophy. This is physics. This is the discovery that awaits anyone willing to look deeply at the nature of existence. The journey is lived. The actualization is happening now. The future is being created in this moment through the consciousness we bring to it. What will you create?